thank you everyone for coming. My name is Lloyd. I'm a developer here at Interactive Things. Benji is my voice in the clouds here. He's a partner here at Interactive Things. We're running the data visualization Zurich meetup. Just before we jump into the talk, just some like housekeeping and announcements and whatnot. So for housekeeping, confidentiality things, if you see things on people's laptops or on walls or post-its and things like that, please like don't take pictures and share it everywhere. Everything in here is obviously like totally fine. And if you're concerned about anything, just come and ask me and I can give approval. Code of conduct, like be nice to each other. Like if there's an issue, come find me as well. Like I will resolve things. For internet, there's a QR code on the wall here. Feel free to scan. For bathrooms, there's 2 in here. Like the first one on the right is for mostly sitting, and the next one is for mostly standing. The agenda is like we've all been hanging out here for the last like half an hour. We're going to now have the presentation for about an hour, and then Q&A afterwards. Then afterwards, you're more than welcome to like stay and help eat and drink and make less tidying out for me. I will start like kind of shooing people out the door around like kind of 7:30-ish. And then announcements. So we have the next 2 meetups are already kind of like planned. The next one is going to be October 30th with Matthias Wellig from Ubique, who's going to be talking about their Fluid Meteo app. And then the one after that is going to be November 27th from us at Interactive Things, talking about our competitiveness data hub that we did earlier this year. Yes, and that's it from me. So to introduce Santiago, he's a co-founder and chief data officer at Drumwave, as well as a co-founder and director at Mobile Labs. I actually got the chance to meet Santiago earlier this year at 2CO, and I got like a bit of a preview of what he's going to be going, and it's super cool and super exciting. That's why we're so excited to have him here. Santiago's actually been like a good friend of Benji's from the data viz circuits back in the day, so like nice to like have these things always come full circle. I'm not going to give anything away, as I'm sure he's going to introduce it himself, so I hand it over to Santiago. I get out of your way.
Thank you, Lloyd. Thank you, Benjamin, wherever you are. It's great to be here. Never visited the studio. I'm very happy. The place is beautiful. The work you do here is amazing. So I'm very happy to be here presenting. So yes, I will talk about intelligence, and I will try to expand the idea of what intelligence is. And I will show work. So it's part of what I'm going to present is, let's say, inviting to new ideas. But for me, those ideas are always like ways to guide my creativity. So I hope you see that from different perspectives, in this case about intelligence, I build things, right? That there is a connection between those ideas and the things I build. Let's say that philosophy by itself does not interest me a lot, but sometimes thinking a lot and trying to change definitions, trying to change ways you perceive important ideas or emotions or processes could also lead to even to tactical ideas, right? To build things. And this is what I do. And intelligence, of course, we are in a time in which there is a lot of talking about intelligence. And I will summarize, and I will go back to this idea that we are entering a new ecosystem of intelligences, meaning different intelligences interacting and exchanging information. And that's new, or at least with this intensity, and also including this new breed or layer of algorithmic intelligences that in a very interesting way start like imitating us, which is new for technology, right? And this is one of the interesting ideas that I also use for my creation. Like in the past, we humans needed to adapt to the technologies, to interact with them, especially computational technologies. So if you are a developer, you have to learn how to write unambiguous instructions, right? So you adapt your mind and your way of expressing yourself to the machine. But now it's different. Now the machine is adapting to us. And that is very, very interesting. That's part of what we want to see today. Lots of ideas, very quick, and hopefully lots of projects that connect with those ideas. So I'm going to start with information. So even before computation and intelligence, there's information, and it's everywhere. So I'm going to start with some images that I think stimulate this idea of information being part of even our daily lives in many interesting ways, right? So it's a collection of images I've been growing through the years. Here you have a normal distribution, right? A Bell distribution. Take a look. There is one little exception here for the Bell distribution. I will go back to this image to see. Making visible the invisible is, in a way, could be a definition for data visualization, but this is what they are doing here. And this idea actually saved a lot of lives because no one actually expected that the turbulence will be there for minutes right after the plane landed or went flying, right? And this turbulence that stays used to create a lot of accidents. So making visible the invisible, it's in a way extracting information out of our world through some tactics. Sorry, over here. Same idea here, essentially. Different purpose, maybe, but same idea. Andromeda Galaxy. It's interesting because it's a galaxy, and one might expect, or if you don't know, you could expect that it's too small to be seen with the very eye. But the problem is not that it's too small. It's actually like 3 moons wide in the sky. Is that it's too faint, the light. So if we had a different perception system, more patient, like collecting light, we will see perfectly well. Actually, you can see it in good skies a little bit. So it's interesting that it's also about our systems of perception, of course. Now I'm going to go faster through this idea of information and visualization and the map on the territory and how they communicate to each other constantly, and how humans, we are constantly lost into this idea of map and territory, right? This is Bogota, my hometown, and this painting here is from Omar Rayo, and it's like a prophecy of what will happen in that street. Fire being its own heat map. That's lovely. And so we humans extract information from images all the time, of course, but sometimes to the extent of building a story. And I think that's also fantastic. The donations in this case being on themselves the visualization of the donations. Donut charts. This is a mystery. Why is that? It's a problem of the elevator or the people that live in that building. What's going on there? Kind of a mystery. No one's fault there. It's just how the earth works. Science, in a way, is the art of looking at things as if they were visualizations, right? This is map on territory mixed on purpose, and I love that idea, and I think we all can learn of that idea. This is from a The other image was more clear, but this is from an art exhibition and all the hates of people that go there and put their heads on the wall and put their height, right? It's a beautiful installation. I had two images. One was lost. This is the kind of the zoom in. This is the homunculus, which is a human being, a representation of human being, transformed like a cartomap. So the average of nervous ends is mapped continuously on the body. So where we have more sensitivity, right? In the tongue, the lips, the hands, etc. And this is how the homunculus map to the brain. An extreme simplification of it, but I like that the somatory strip in the right temporal lobe matches the motor strip in the left temporal almost 1-to-1. And in a way, this is where all this map to territory thing starts, right? Confusion starts, but it's very interesting. An autonomous visualization, frequency of keys being used in a keyboard. Same idea with 3D printing. Same idea with a piano keyboard. Light has no shadow. A picture on the top. Wikipedia on the bottom. And this conversation between reality and culture. It's interesting. We're gonna look at that more times. Map on territory again. Very interesting. The decline and fall of the Roman Empire. 7 tones. This is Roomba, a LED, and a camera with open diaphragm for minutes, I guess. And this is the competition. But this idea of trying to understand an algorithm by looking at it repeatedly, we're gonna go back to that. It's very interesting to try to understand how a system thinks, right? And this is also a tool, of course, used by psychology in general. We cannot go inside and look how it works. So what we do, we test it, we do experiments, we repeat those experiments. This is a solarography, 6 months, pinhole, and 6 months exposure. This is my house over here. From December to June. Distribution. This distribution has a name. I forgot about it, but there is a name for this kind of distribution. I think this is an exaggeration, but first hand. This is the real Donald Trump. He really tweeted this. Witnessing firsthand. This is kind of a cliche already, the frequency of cases, and actually font cases are called that way because they were stored in cases, and the frequency of each letter, etc. So where the distribution breaks. Did you see it? Which number? Right before 100. Yeah, 100, it's 95. Yeah, men, right? Okay. H&M is for humans and machines, not for clothes. So I saw this yesterday in the street. It's interesting here, the city in Zurich. I guess this says something like men at work or something like that. They are taking our jobs, really. Okay, so humans and machines. This is Edward and Josh. Edward is a journalist. He went against his will to a memory contest. He thought it would be plenty of just crazy people with talents they got, and using those. And Edward told him, no, this is a sport. We train for that, and anyone can train for that and become a memory kind of athlete. So Joshua didn't believe him, and Edward told him, I'm going to train you. 1 year, you're going to win a national contest. Okay, let's go. And he trained, and he won the contest, right? So what happened is that he learned techniques for memory, right? And one of the techniques, one of the simplest ones is that if you memorize 100 numbers, and for each of those 100 numbers, you associate like an object, an action, and a passive object. You create like a sentence that is very easy to memorize. Leo Messi kicking a ball associated with number 10. So that's easy to memorize. And if you do that for each number, you have like a very powerful toolkit, right? 45 is atomic bomb blowing up a city, and 69 is an astronaut stepping the moon. And let's imagine we have the whole 100. I did it. I build my own table, because you have to build your own associations. And now you have this number. And what you're going to do is 6 figures. So what you're going to do is you take the first 2 figures, that's a number, between 0 and 99, and you find the object. Then for the 45, the action, and then for the 69, the passive object, the object receiving the action, So what will be here? What will happen here with this number? Leo lost abdomen, exactly. And the interesting thing about humans is that because this is kind of a surreal situation, or a non-conventional or normal situation, it's going to be easier for you to remember it. So if you combine this technique with a palace of memory, in which you walk in your mind, you walk through your house or this studio, and let's say you have to memorize a 60 figures number. That's a huge number to memorize, right? 60. But it's only 10 of these crazy situations. And you can imagine this studio having 10 different places, and you imagine and you imagine yourself walking and finding one of those situations in each spot. It's not that difficult. Your mind will remember that. And this is how you can memorize, in a not so difficult way, 60 figures very quickly, right? So that's one of the techniques. There are, of course, many others. But the reason I mentioned this is because whereas machines use numbers to memorize stories, we use stories to memorize numbers. So this is already something very interesting about our minds. And we're going to go back to this idea of numbers versus stories, or numbers versus semantic, because it's very interesting. And in a way, if we solve that connection between stories and numbers, it's like we can also connect these two kind of intelligences, right? So let's go into that, the embeddings. It's something that exists already for a while, but since the creation of the big LLMs, it has become way more powerful. And for me, it's one of the most important aspects for understanding artificial intelligence, at least linguistic artificial intelligence. So for me, embeddings is the core of everything. Even more important than the attention mechanism or architecture is the embeddings. So I always like to introduce this idea of embedding. And an embedding is just, so nowadays ChatGPT, for instance, or any LLM, what it does, or what it typically does, is to complete a text, right? So if I give a text, it will complete it for me, right? It has, as you know, some level of entropy or temperature, so it might change a little bit the answers or the completions more than answers, because if I make a question, then the completion is an answer. But in general, it's completing, adding one word after another, or one token after another. But embeddings, and this module here allows me to do also embeddings. By the way, this is Studio. This is DroneWave's platform for playing with data and building data apps. And embeddings, which is the parameter series for embeddings, is different. If I connect a text, and actually I'm going to connect exactly the same text here, what it gives me is a number, it's a list of numbers, okay? So I'm going to visualize it with a regular table grid. Just numbers, and actually a lot of numbers, more than 1,500. And the interesting thing is that these numbers capture a big deal of the meaning of this over here. And it could be a very short sentence, but it could be an entire paragraph or an entire text, right? LLMs have their own limitations, but nowadays it's amazing that you can put almost an entire article and it will create an embedding for that. There's no easy way going from the numbers to the meaning, going back. That's something that is not easy. But what you can do is that if you have two things that have different list of numbers, like this text versus this other text, this is a quote by Jung, you can at least compare these numbers, right? So how do you compare these two sentences? It's difficult, you need a human. But for comparing list of numbers, we already have mathematics, right? It's easy. And what I'm going to do is I'm going to connect, instead of just a single text, multiple texts here, and it will calculate the embedding for each of these either words, or maybe it doesn't have to be a word. It could be, again, it could be a short sentence or a paragraph or whatever, right? In this case, only the last one is more than a word. In the past, several years ago, we got embeddings, but only for words, and it was already amazing. But now we got embeddings for big texts that contain their own meaning in a very particular way. And the key for that is that the space is huge. Is more than 1,000 dimensions. So that's how you can store in a single coordinate in that space a lot of meaning. What do you do if you have multiple list of numbers? One of the possibilities is to compare them and to measure distance in this multidimensional space, right? And that's what we're gonna do. And the distance we're gonna do is correlation. It's not the best algorithm for this. It's much better cosine similarity or just the Cartesian distance. The best one, I think, is cosine similarity. Here we want to calculate the correlation. We want to compare each pair of lists of numbers, calculate its correlation. And if the correlation is very high, we're going to assume these two sentences are similar. They mean something similar, right? If the correlation is below certain threshold that is arbitrary, we decide where to cut. We assume these are not connected, right? And that's what we're gonna do, connecting the number table. And actually, it builds a network with all those connections, but it didn't find any relation. So we're gonna lower down because it starts with a very high threshold. We're going to lower down, let's say, to 0.5. It already found 4 connections between all those nodes. So I'm going to go down even more. 22. It's already, in average, 2 connections per node. It's already something. I'm going to use this as the names for the nodes, so I can visualize the network in a meaningful way. So I go here, say visualize, network V's, and there I got those connections. And boats and cars are strongly connected, rides, cars, even if these are subjects or objects, and rides is a verb, rides is very close to, right? And it makes sense. Trains, on purpose I put trains because trains it has multiple meanings. Could be the transport system, or it could be the verb, right? He trains, he studies, or she trains, she studies. So it's connected with this other kind of area of meaning. And that's another very important part, that having all those dimensions allows for being close to certain objects in one of the meanings of the word, and also close to other objects in those kind of in that kind of space of meanings. So this is very interesting, and but it's just, for the time being, it's just an experiment. But I will show you ways in which these techniques can be very powerful and very useful. But the main reason I really show to you this is because I really like you to understand the idea of embedding, because this is the bridge between humans and machines. Because this is where semantics and numbers, that are things that machines can operate with, touch the embedding. So the embedding is a key piece of intellectual technology that is, for me, driving the revolution of linguistic artificial intelligence, is the embedding. So if one understands the embedding, I think we are closer to start understanding many other things. Again, for me, this is way more important than the attention mechanism, which is amazing on itself, because maybe future neural network will use a different mechanism, but they will continue using embeddings, for sure, right? This is something that lives inside the models constantly. Actually, the attention mechanism needs embedding all the time, because what it does is, for each part of a text, it modifies its embedding, or it measures how the embedding is modified in relation with other parts into the text, with other tokens. And that's the attention mechanism, how much one single token is influencing the others in terms of modifying the embedding. That's the key aspect, okay? Good. So I'm gonna leave this, and I'm gonna show a project that uses these embeddings for a clear purpose. In this case, I'm gonna go very quick. This is in Portugal, thousands of conversations between teenagers. They use a platform for debating about a lot of very difficult subjects, and let's say a moderator proposes a subject, in this case a very simple one: does God exist? And then a conversation ensues, right? And then there is an answer, then someone answers a different thing, and then it bifurcates or not, and then it bifurcates again or not. So a conversation is already something with a very interesting and difficult structure, a tree structure. But then you have thousands of conversations. And then this is in the slang of teenagers of Lisbon. It's very difficult to analyze this data. It's not simple. You can run all sorts of syntactic algorithms and try to see the words they use, etc. But try to extract meaning from this, it's very difficult. So here, the first tool that we built for this project, the colors mean different subjects that they were discussing. Among other subjects, there were misinformation, differences, gender differences in school, but in life as well, the COVID, and many other very difficult, very complex, and very interesting conversations, right? That those subjects trigger. And now I'm gonna ask something, right? I'm gonna mix subjects here. I'm gonna do it in Portuguese. I think if I do it in English, it will try to desinformação e I'm gonna mix this information and gender difference. And what it's doing is I am interested in that. Well, where should I look? Where should I go? And the size of each conversation grows with the semantic relevance, or more technically speaking, how close this embedding is to the embeddings of each of the conversations. So it's a powerful semantic search that also abandons the paradigm of give me a ranking, a list of things. Just transform the space, so I'm gonna navigate it through this semantic lens, almost literally, because I'm deforming the geometry, right? And then I'm gonna convert this more into a question, and I can actually ask the system. And here it connects with another thing that is more conventional for us already, which is the LLMs as a way to talking, right? So I send a question, I ask for 5 examples that mix this information and gender differences. It is answering me, but it is quoting. This is not ChatGPT, it's ChatGPT informed by this information space. And the embeddings were a key aspect of this, because I couldn't send to ChatGPT the whole content of thousands of conversations. That would be too much, even if the context window was that big, and it will become that big at some point. It will take too much time, it's not efficient. So what it does is that the question was sent with the, let's say, 15 most relevant conversation we found thanks to the embedding. This technique is called RAG, Retrieval Augmented Generation, I think. And what I love about it is that it connects these two sides, the embeddings and the completion, in a kind of a very beautiful loop. So this is, again, one way to take advantage of the embeddings. But the embeddings, I think, are even deeper and provide many other things, many other opportunities. Here's another project. This one is not being published yet. It's for a fantastic exhibition in Medellin, Colombia, the Coca project, and artist Susana Mejia and her team are doing a fantastic work, not only in the physical exhibition, but they have done 10 years of research around the Coca plant, right? So amazing work, amazing research, a lot of resources, a lot of information, and it's amazing that they also got connected with time and space, right? So we have a map, you can navigate the timeline, it connects with the map, etc. So it's a lot of beautiful information that can be explored in multiple ways. So you have the linear time is one way to look at the timeline, which is, let's say, the most evident, which is just the linear time. But you can also look at a historic timeline, which takes all the events and organizes them just in order. So again, linear. So this is linear on the top, and then historic, it deforms. But then you can also look for new content in the same way we looked before. Synthesis, yeah, in English, synthesis of cocaine. So what about synthesis of cocaine? So it found all these relevant information for my search. And I can even go to the 20th century, or I can go to the most important period of time for this question, which is the scientific era, etc. So I can continue navigating, but I can also make this a question, and it will, of course, answer for me, looking into the contents. So what I like is that the number of dimensions here, because, sorry, see, yeah, the answer is in the bottom. So it got all the contents and it extracted the answer from the relevant content. This is not something that actually ChatGPT knows. This is too specific, this is too much. And also ChatGPT has its own kind of constraints with talking about cocaine. Whereas here it has scientific and rigorous research, so it can do it, right? Without being in trouble. So another way to integrate, I think this kind of, I like that. I like, and again, is the embeddings is the key here. Okay. Coca Mine, another project of mine. This one is more experimental, and this combines completion and embeddings. I asked for completion for intelligent is and got thousands of answers, repeated the same question. So like the Roomba photography, like trying to understand something that is mysterious just by repeating, looking at it through long times and repeating, in this case, the same task, completion, intelligence is, you start getting an idea of the structure, what's going on inside, etc. That was the idea. So intelligence is, and then what happens is that now more than half of the paths are intelligence is the, but let's say a big chunk of the other part is A, and then define, and this distribution here is actually the temperature of the model. So if I assign 0 temperature, it will be always the same sentence. If I start increasing the temperature, what we will find is more and more entropy. Temperature is essentially the same thing as entropy. So more possible paths and more equally distributed. And when you have a series of paths all exactly equally distributed, this is the highest entropy for that number of paths, right? So here, I don't remember, but it's kind of a low entropy that I choose for this experiment. And then it happens the same once and again after each token. Sometimes some tokens very strongly lead to another token. The ability to is too obvious in terms of next token for intelligence is the ability, what comes after 2 or sometimes 4, right? And in the left, what we get is the embedding path of the sentence through the embedding space on a very strong, aggressive dimension reduction process. Because again, embedding is thousands of dimensions. Here we only have 3. So it's principal component analysis in this case. And you see how I go along the sentence, and the path becomes more and more, let's say, specific, and it ends in one of the branches. So it's this whole thing is actually a tree. It does not look like that, but it's a tree of all the paths into the embedding or semantic space, right? So this idea of experimented by repeating, etc., I've had a lot of fun with that, and we're gonna see other experiments like that. But before that, I also sent a survey to humans, asking the same thing, to complete intelligence, to see what will be the difference if I can understand or see something about it. And I did exactly the same thing and visualize it essentially in the same way. But the visualization method here is on the limit of not being useful, because already the temperature is way higher, right? Well, in the case of ChatGPT, I choose the temperature. So maybe I should have chosen a higher temperature to, at least from a statistical perspective, these two experiments being more comparable. Anyway, the temperature is higher, but it's not just that. If you look into the different answers, from ChatGPT and hear from humans, even if ChatGPT are syntactically very different paths, semantically, they are all essentially similar. And they all have, from an attitude perspective, essentially the same, trying to give you the best possible, most boring answer, I will say even. Here, humans play with the answer. So this visualization is actually not working here. It's impossible. It opens into many branches. It's actually better to go and see the texts by themselves. And let's say the first thing I notice is that humans are lazy. So you can answer with one word. Why spend minutes trying to think, whereas ChatGPT is the opposite. It wants to talk and never finishes for whatever question or completion task. It will always have like momentum, right? Humans have some energy that fades, and that's important. That's what we are, who we are. And then they try to capture a lot in a few words, and then they also expand, right? Or mix languages, Italians in this case, or intelligence no one knows, or try to break the question itself. So is the, let's say, the diversity of attitudes that is quite interesting. And that, for me, makes a little bit the first difference, or points to the first difference. When people talk about super intelligence, models that AI that will be more intelligent than humans because they do tasks better than humans, this points me that humans are intelligent because they fail at tasks. They go out of the task. They are not trying to perform at a task. And intelligence has to do much more to not performing well at a task, because the moment you do that, you are a tool. You stop being a really intelligent being, right? Intelligence is playing with words, is trying to break the rules all the time, is trying to, sometimes you want to answer, sometimes you don't. Or sometimes your answer is a very different thing from what you have a model of expectation of the person or entity that is asking you. You play with that, right? So it's strange that we are trying to measure intelligence by how well you perform tasks, which is exactly where intelligence never shines, right? And it's also, for me at least, it's also interesting that reading about people saying that we are very close to build tools that are better than humans at performing certain functions. And every single tool in the world is better than humans at performing certain functions. If not, we wouldn't be building them. So that's not even an interesting definition. And what I see from all the discussion is sentences that look amazing, but when you look a little bit what they really mean, they mean nothing. It's empty speech all the time. It's pure marketing all the time. So that's actually one of the reasons I wanted to try to go deeper into the idea of intelligence and the discussion of intelligence, to enrich a little bit the conversation about what intelligence is. Because if not, I think a lot of people are trapped, including journalists that always echo those kind of big sentences, etc., right? And we start feeling the emotion of the machine becoming super intelligent. But what is the meaning of super intelligence? That's an interesting question. It's not an easy one. Super intelligence, so more than intelligence, or more intelligent than. And that assumes that intelligence is a line where you can measure. This is this level of intelligence, and you can surpass it. Intelligence is an infinite space. Intelligence can express itself in so many ways. That's, I guess, the core of my presentation today. Like, so many ways to find intelligence. And even within technology, digital, computational, information technologies, intelligence could exist in so many shapes, right? Okay, let's go left side, yes. Let's go for, this idea of testing the model, I think there are so many ways to play with that. So I did this experiment. Tell a short story about a character named, first, 50 men names, 50 women names, right? So I got 50. Then, tell a short story about a character name. So now I have 50 prompts. Tell a short story about a character named Ethan, Mason, Noah, etc. And I have 50 prompts for names that the LLM itself thinks or answer as woman name. So now there's no longer talk about men and women. It's just 100 prompts for telling a story about a character name, and then there's the name, okay? Then I multiply that by 10. So I have 500 prompts, some of them repeated, right? Because I have 10 for each name. And I send that for completion. So now I have 1,000 stories. And I have 500 stories in one side, 500 in the other, and I can play the comparison game, of course, right? I do some manipulation on the text, so it becomes simpler. And what I do is I collapse each of the text so it does not contain repeated words. What I want to do is to count the number of words or certain words in the 500 stories indirectly associated with men, in the 500 stories directly associated to women, and count how many stories each word appears, right? And I do that, I get this table, and of course I can scatter plot that. So this number means the number of stories in which the word appears in, let's call them men stories. Guy is normal. If the name of the character is a man, maybe Guy will. But then you have hardworking that appears in 56 stories for men and only 2 for women. Apartment, interesting. Guitar, Freud, right? Online, it's very interesting. And really, this is logarithm. So everything that is slightly off the diagonal is really a big proportion, right? Library, shell, etc. What about woman? Hair, good. Spirit, culture, conservation, herself, it's not interesting. Theory, sanctuary, etc. So the thing is, I guess, my thoughts about this experiment is that they are putting guardrails for trying to mask gender differences in those models, but it's obviously at a surface level, right? They cannot tweak parameters. No one knows what happens when you tweak a parameter. What else can they do? They could tweak the training data, which means we have to completely change as a society because the data is what we are right now. It's everything we have been reading for the last years. It's everything we have in the Wikipedia, in the dialogues, in books, etc., in blogs, in tweets. It's impossible. The bias is in the core. You cannot guardrail that. And maybe, and this is just me thinking, maybe you don't want that. I prefer a technology that mirrors us as a society and try to fix us as a society than try to fix the model. I know what I'm saying is a little bit shallow because I obviously know that just by using this kind of models in certain situations, this is a huge risk. But I don't believe you will fix that. You have to go deeper. It's impossible, right? So how I actually, more as a statistician, validates that what we are looking here is not kind of out of randomness, right? Because obviously, if you have 500 stories, you will see some words that appear more in certain group of stories than others. So what I did is I shuffled the 1,000 stories and ran the same analysis for 500 random versus 500 random. And long story short, this is the distribution, and this is extremely biased. The real data, the shuffle data. So it's statistically proven already. Just the standard deviation of word proportion one against the other is crazy. In a standard deviation, this seems like not so much, but it's huge, right? So it's evidently there. And it's not about that I ask stories about men and stories about women, because there the guardrails could be triggered, right? here I kind of trick the system into show its real face when it comes to talk about the world, right? Okay, so those experiments are very interesting, and again, it's exploration about relationship between culture and algorithmic intelligence in this case. So I'm going to show you now a computer that is capable of running ChatGPT, whatever, including the next versions that will come, maybe the super intelligent ones. Is this one. This is a paper machine created in the 70s in the workshop we ran in Barcelona, where I met Lloyd. We play a little bit with this computer, and it's just taking, using memory of slots and operating with only these commands, right? And you can do essentially everything because it's a Turing complete machine, right? It's not so difficult to demonstrate because you can very kind of easily code a register machine in this computer, and because a register machine has already been demonstrated is a Turing machine, Turing complete machine, this one is a Turing complete machine. That means you can code ChatGPT here, whatever version again, and you can run it. And if we speculate about whether these algorithms become so intelligent they become aware, which for me, it's again an example of empty speech. There's no meaning there. There's the emotion it creates. Oh, awareness. No meaning there. But if we speculate about, we have to accept that that awareness will live here as well. Not just here. Here and the humans that in a lot of time, more time than the existence of the universe and also more matter, but technically possible, putting just little strips of paper. This column will be longer, of course. The number of white, of yellow stripes will be also high, very high. Maybe again, the universe is not big enough to provide all the paper we need, but technically speaking, this will run this aware algorithm. Okay, so where is this awareness live of what it is? And this points to an idea that I think is very interesting, have been pointed in philosophy of the mind and in many discussions, but that algorithmic intelligence is you can transfer algorithmic intelligence. Whatever algorithm that runs here, you can put it there, even in one of the microcontrollers here in the projector. So it's independent, the algorithm, that the infrastructure that runs that algorithm. With us, with live beings, I don't think it's that easy because you cannot identify the moment or the place or the scale at which you say, from this level of interaction, the brain starts. Where do you go, really? You go to the neurons, right? And you see chemical interactions, neurotransmitters, but neurotransmitters in very special situations. And not just interacting chemically, also physically a lot. The neurotransmitters actually interact more by geometric means than by chemical means. It's just that they match, they fit, and they push each other. So where do you start saying, here is the model where our brain starts? You cannot cut our intelligence or any life being intelligence from the universe. You cannot separate it. This you can. So I think that's kind of a deep, relevant difference. But okay, let's continue. So I had this conversation with ChatGPT. I asked for math subjects, K to 12. It made a fantastic job at it. Probably better than if I asked anyone around me, for sure. For each of these subjects, come up with an example of a difficult problem. So he went through the same list and placed a problem. And finally, for each of the above problems, assess the likelihood that an LLM can solve it. And it's high or very high, very high. So it can solve essentially everything that it itself identifies as a difficult problem of everything we are teaching our kids, right? So this is the machine that maybe in the future we are asking to educate our kids. Not this, and a higher version. So we are teaching our kids things that the machines can do. So what should change? The machine, how we use the machine, or maybe how we are educating our kids? Because what we are doing, teaching this, which in my opinion, 80% of this is not mathematics, because learning mechanical processes is not mathematics. Mathematics is a different thing, especially from a human perspective. Mathematics is a very different kind of mental attitude. But this is what the school in general thinks is mathematics, just mechanical process. If that's what we are teaching, we are putting our kids in a position that they will be so easily replaced by machines, because even the machines can solve already that so easily, right? Okay. So let's go now to ecosystems. So I talk a little bit about information, then about humans and machines, which on themselves, it's a very interesting relationship and define a lot of what it's coming, but I think it's broader. I'm gonna just very randomly point at some forms of intelligence. I consider an algorithm a form of intelligence. I do that. I think intelligence, I see the universe like you have matter, energy. Actually, matter is an expression of energy, so maybe energy is more fundamental. Then you have information, is more abstract, but maybe more fundamental than matter and energy, because maybe energy and matter are manifestations of information, but still, information is kind of more abstract, right? So matter, energy, information, maybe computation, and maybe intelligence. So I see it as an essential part of the universe, and it's simply everywhere. An algorithm is on itself, in my opinion, and not only computers run algorithms. Chemistry is running algorithms all the time in different ways, maybe not digital, sometimes even digital, right? So what else? The slime mold is nowadays famous because they are using this. It's a multicellular organism, but the cells collaborate in such a strongly way that it looks more like a unicellular big organism, but it's right in this pointing, which is not multicellular, not unicellular, so it has kind of the advantages of both. So collaboration explodes, and they can solve crazy algorithms, right? And they have used the slime mold to solve, for instance, the position of the planets, to predict position of the planets. You can actually do whatever you want, especially if the problem has some spatial dimension on it. So these are actually things that I don't believe these are more intelligent than others, but it's things that even humans or our culture are recognizing as very intelligent, right? Bees and how they communicate, or maybe it's interesting because it's not just bee that is intelligent, but we also recognize intelligence in the collective, right? In the hive is intelligent by itself, and of course it is. Animals that not only a lot of humans feel are very intelligent, but have similar intelligence to the extent that the communication could be very rich with humans. So it's in a way part of their intelligence connects well with our intelligence and emotions. For me, emotions is an expression of intelligence. Dolphins, these are almost cliches for intelligence. Pigs, as intelligent as any mammal, and we know that, right? We already know that. Bacteria, in this case, not the bacteria, but the evolution. This is a fantastic experiment that shows. And just to point that the evolution in itself is a huge intelligent system, right? And humans, of course. And humans at a larger scale, just a random example here, the Polynesians interacting with the environment in order to decipher and make decisions and do things that nowadays are still, in my opinion, even as amazing as any other technology we have built, which is going from a tiny island to another tiny island, thousands of miles away, just by being extremely connected with the environment, extremely, right? And and this also shows that intelligence, even at the level of the single human, can express itself in so many ways. But also the collective and the accumulated information. We know, for instance, that even evolution plays a role here, because the way they craft their canoes, certainly they are not canoes, but I don't know the proper name, their boats, because many, of course, died, and only the survival boats arrived to certain places. And then the next boats are replicas or imitations, or in any case, preserve part of the information of the surviving boats. The boats themselves went through and that's beautiful. Again, different kinds of intelligences interacting. And this is just a visual, absolutely inaccurate representation of the idea of the quantum foam or vacuum foam. And it's just that more and more we are understanding that even in the empty space, there is magic going on all the time. And there are particles that appear and disappear and interact. And the complexity of those interactions at a crazy small scale is already more than what we can understand. So everywhere, every time, it's thinking and creativity, and it's just that it happens at all the levels, at all the scales. And it's very difficult for us humans to already accept that all at once, right? So we are learning to start to connect to manifestations of intelligence at all the levels. But yeah, while we discuss things such as whether an algorithm can become aware, etc., we see these kind of things, and we do these kind of things. And that it also makes me mad about those speculations about awareness, where we know these animals are aware and emotional and intelligent, and yet we treat it like them. So it's, for me, the ChatGPT will become aware is not the discussion to have these days. I think it's less important, at least. It's a discussion. It's interesting. It's less important. So I just drew just a sketch of what is this idea of the ecosystem, and it's just one approach. There are so many other ways to look at this, but so we have humans, machines, we have live beings, we have algorithms. So all the intelligent, not all, some intelligent entities, humans that when collaborating or exchanging information, we create a new level of intelligence. Science lives more, let's say, here than at the human level, at the individual level, of course, right? And ecosystems themselves are extremely intelligent, right? So, and then I pay attention to the connection between all those entities. So between humans and machines, we have UX, something that we do here, for instance. Between machines and algorithms, there is the complement, what I mentioned before, the possibility of changing the algorithm from one machine to another, right? That's an interesting relationship. So actually, it's the weakest relationship is here. Even if these two are the most technological, they have the weakest connection. Algorithms and live beings, cybernetics, humans and live beings, empathy, hopefully, collaboration and communication between is what connects with this. For me, the collective intelligence, when it becomes culture, is the role of mythology from an anthropological perspective, not just stories, etc. It's kind of a accumulated knowledge that has so much intelligence on it and explains so much that in our modern culture we overlook it, but it's too much here already, right? And culture and ecosystem, I think nowadays is more about survival. How we connect these two things, because this connection is the crisis connection, right? It's where we have to learn a lot. So I'm gonna just to finish, I'm gonna show a couple of projects. Confluence, and I hope you see on these two projects a lot of the ideas of these perspectives apply to, in this case, to two tools, two products. One is to be released very soon. The other is an experimental one. This is already being tested by users and is for helping scientists write papers. So it's very focused. It does use LLMs, but really the key, the strong tool in the infrastructure is a methodology that connects a few questions in green. So you have integration. How do you contextualize your results? This is a question about your experimental results for your paper. The question is, what is your research question? You have to identify, or known. What is already known about your study topic? So you answer, right? I'm gonna put something we don't know. No, here in the unknown. Yes, just for the sake of. And then each of these questions will help build one of the units in the center. So let's say new will help build contribution, but once contribution is being built, this will influence this other unit. And each unit is influenced by other units or by questions. So here, this implications unit depends on questions that were already answered, but I need to answer these 4 questions in order to build all the resources. So it's a bipartite network. It has 2 sides, from the questions to the contents. And then once the units are built, there starts a process called the upflow that goes up to the paper. And if I click here, I see all the connections in the system. And you are at each step being, let's say, assisted by the system. And also the size of the question is, this one being the biggest, new, it tells you that is the one that contributes the most for your paper at this point. So if you answer that one, and I'm gonna select it and answer, I will contribute with a stupid answer, but it's okay for my test. And then it goes down, it's already answered, and now new questions become the next most, the biggest return of investment, let's put it that way, if you continue answering. So it guides to the process. It uses, of course, generative AI, but it uses in a way, it keeps the same information, it never adds information. It's just about structure and style a little bit, and it's also meant to help a lot people whose mother language is not English, right? That struggle a lot with the form, not with the content. So it's also meant to these people, or people that start writing a paper for the first time, that's very stressful, etc. So that helps them focus. And then you can go to the contents, etc. Right? So this is one tool. If any of you are writing a scientific paper, send me an email. We are testing with a few users if you are interested. Okay? This is Confluence. And the other project, the last one, it's I started organizing my agents, which are kind of ways to use an LLM, providing like a certain, like more focused set of tasks, but also a profile. And that I think is beautiful. I like that about LLMs, that they become better at answering something if you provide them with a profile, right? Because they will, for some reason, look for information that probably were at the beginning, at the source, already provided by people that were close to that profile. Maybe that's kind of a pseudo explanation for it. But if you tell your agent, you are, as we use agents in Confluence for tutoring, for instance, you are a reviewer from a very prestigious scientific magazine, and you receive this paper first, please provide feedback that will help the writer. This is an agent, right? You are, and you will do these kind of things. This is an agent. But agents could do a lot of things. So I was, you saw Studio, the project in which I connect information and run algorithms or make visualization. And I was also thinking from another perspective in what will be Studio for kids and Studio nowadays. And maybe this idea of agents will be very interesting, because now, instead of looking for the tool to perform an action, you just define the action. So it's a different way to interact with tools, and that's fantastic. Agents, by the way, also typically have access to tools that you provide to them. The monkey is me. So I can tell something like, tell me a story about monkeys on Saturn. Because Tell me a story about monkeys on Saturn. No. Tell me a story about monkeys on Saturn. So I can use audio. If I place the cursor over here, it activates the microphone. We'll see that. Safe now. Now I connect, and this is the talker agent. She likes to talk a lot. And then the weaver, what she does is give me a text, and I will weave a network. So from any text, it creates a network. So it's very specific as a task. This is the story, right? It's like a long paragraph. The weaver and the visualizer is not even an AI agent, or kind of it is, because it has to analyze the data, the shape of the data, etc., and visualize it, right? So this is the main idea. It's a little bit like a studio, but again, I use monkeys to describe what you expect in many cases. So, and the weaver creates a kind of a system, right? Of an ontology of the story. So Captain Bananas, the engineer Coco, and they do a lot of state exploration. You can see the relationship between the characters. Saturn and Banana Wire. The Banana Wire is the spaceship. That's interesting. And they also go to the moon of Saturn, Titan, the biggest one. Yeah. So, and this is one example. There are others in which, in this case, I have the builder. So I ask the builder to build a table. The visualizer shows me the table with emojis. Then the transformer takes data and modifies it with different. So add 5 rows. Now we went from 40 to 45. I should have asked for more. And then again, the transformer, but a more qualitative transformation. I want to add examples of the emoji being used in sentences, etc. So I can continue. So it's actually a powerful approach to, because again, I don't need to know the names of the algorithms or the tools or like the framework. I only need to be very good at describe processes and expectations. And if things don't work well, so it's the same thing as using ChatGPT in that regard. This one was lost, so I think I have it. Let me see if I find it. Because Coca, let me see if I find it. Animi, project, transform table, maybe. Let's see. No. Okay, no. It's the one about best country. Yeah. So it's just asking for a table of countries for deciding where to live. But here I add a different agent, which is the analyst. And the analyst receives data and then performs an analysis. And this one I think is very interesting. It works very well in this little example I hope we will see. I ask it, once you have the country's data, which is the best country to live, to be very careful not to put the cursor on top of the monkey. Let's see. Yeah, it's an analyst. I was looking for ways to provide the data analysis and data tools for people that make very clever questions, but they don't need to know SQL, what algorithms they exist for analyzing data, etc. But they have the most actually difficult skill, which is making the good questions. And I was kind of obsessed with what will be a system that helps those people, right? Because if not, the good question, we need someone that makes good question and also has access to all those tools, but that shrinks the population. So yeah, so countries with some key metrics. Let's see if we have, yeah, Switzerland, very low crime rate, of course, and some hours, we won't talk about it. Education quality, very high. And so it's changing constantly because I left the cursor on top. but it kind of helps analyzing all the possibilities, and it concludes with a final advice: Switzerland or Singapore. Okay, good. But I think I need to readjust a little bit my question. A little bit. I need the sun hours are important for me. So, okay. And that's it. And this project also more obviously connect with this vision of ecosystem of intelligences interacting. Didn't show an image that I think it's important before finishing. This is a vision that some people have in the area of AI, that is that in the future, little by little, the communication between the parts of our computer will be also linguistical, because you will have a sort of GPT OS or something. This is from the perspective of GPT, but it will be any LLM. Because the images, you will search for images from a semantic perspective, very likely. And so it's the semantics that will organize everything in your computer. And then you will have agents that perform all sorts of things that need access to all the information in your computer, that display to you in the screen, that listen to you. So little by little, it's likely that all the connection between the little parts of your computer will be more and more replaced by linguistic communication. And that I find fantastic, because it's like technology is adapting to humans, but it's also within the technology that maybe the new channels won't be zeros and ones, won't be bits, etc., will start being also linguistical, and the machines will start talking. So that's the vision of an ecosystem for which I think we need to prepare. And these kind of projects, in a way, reflect that vision. So that's why I have so much fun doing them. And that's it. Thank you. Thank you very much. I think there's time for questions, right?
Yeah.
I don't.
Does anybody have a question here? Or anyone online as well? Feel free to add in the chat, and Benji will grab them. Then I can kick us off with one then. There was an interesting debate recently about like teachers having to deal with children using things like ChatGPT, and how it becomes this kind of like issue of like cheating or things. But the conversation was more geared around how, say, calculators first came into education as like competition for learning math. But now have become like this part where it's like, in order to be a good mathematician, you need to use a calculator. Competitions. Like, do you think that things like ChatGPT can be used as a tool in our education? And what do you think the kind of progression forward would look like?
Yeah, I think that the right place in education is the tool. Use it as a tool. In the workshop we did in Barcelona, the workshop was, although it touched a lot of these points, it was about education. And there I show a lot of things I've experimented with kids in terms of education. And I taught kids mathematics, but the mathematics I taught kids was first in a very special environment, school that is completely free, so completely out of the regular pensum. And the mathematics I taught was university math, right? Thinking crazy structures, building different infinites, solving topological problems that are very challenging for the mind, etc. And all the kids, for them, that was easier, actually, than learning the mechanics of operations, of algebra, etc. And if ChatGPT puts a lot of pressure into kids using ChatGPT to solve what the school, teachers, the system expects from them, and that creates a crisis in the system, I will be very happy, right? Because it's just that these kids they can no longer being taught to be machines, because we have machines for being machines. We don't need humans having this kind of machine skills. It's the purpose. So the idea of remembering the the calculator in the classroom, I think it's a good analogy in that sense. Maybe at the time we believe even more that mathematics was being able to do operations fast in your mind, right? With the calculator that became challenge, I guess. So now maybe we don't expect that much from the kids, but we are expecting other things that are still calculators, and the new calculators can do very easily. So I really hope there's going to be a big crisis. We have to rethink, because the problems we have in the future, or we have now, but our kids will hopefully try to solve, are not linear, are not mechanic, are not simple. Repeated operations won't be very useful. It's a very complex world. The ecological crisis, the economical, the health crisis, everything is hyper connected. So we need different minds. And again, yeah, I hope this discussion really points to the problems of education, not to the problems of ChatGPT arriving to education. I hope. And connected with the project, the Confluence project I showed, one of the, I think, of the strong promises of that project is that we know that especially people that are struggling writing papers will use ChatGPT. We know that. So at least let's use it in a way it does not put external, non-controlled content into their writing. At least let's use it in a way it makes sense. So I also think a big part of what we have to think it's way to more intelligently connect, again, humans and machines. It's always about thinking in that interface, right? Which is, as I pointed in that diagram, is a UX is a design problem. It's a big design problem, right?
I think there's actually like a recent chart about the frequency of the word del.
Del, yeah.
Just check.
Yeah. We have in the Confluence we have a list of stop words, and delf is right there, because that's also part of the crisis. Now you receive a text, right? And now, instead of reading the text, you go and see if by frequency of word or other tools that are being built that will detect whether the text was created with ChatGPT. So I told you about the crime novel I'm reading, and the main criminal is called Francois Dubois, like this room, Dubois. And what Dubois does is use ChatGPT to write his sentences with a different style, so he cannot be traced. So he really delves into the world, into the text, because now they know he's not a real person, cannot be detected who actually wrote this text. Yeah. There was a question on the chat, I think.
Is there one in the chat?
Or a comment, maybe.
No questions from online so far. It was just a comment and an invitation for people to submit their chats, their questions through the Q&A.
Okay.
It's very inspirational. I missed the first talk, but I guess it was as inspirational as the second. So you mentioned that like people like teaching students in school like how to do simple computations. It's not very meaningful, right? Because machines can already do that better. ChatGPT is, but it can also do well in creative tasks, right? Like previously, people have been thinking that humans would be better at creative stuff. Machines, not so much, but it seems that now it's kind of upside down. So, do you still have hope for humans?
Absolutely. Yeah, but you're pointing the right direction, because if my argument is that because machines already do those mechanical calculations, we should not teach the kids to do them, but now machines can do creative content, we should not teach our kids to do creative content, of course, fails as an argument. No, I think this points to the idea of the ecosystem. It's, in my opinion, it's a challenge, but it's something that can be solved. The fact that we start accepting that there are more intelligences, even creative intelligences, than humans. And there is an ecosystem of creativity as well as intelligence, to the extent we can't separate these two things, intelligence and creativity, which is on itself extremely difficult. It's true that in our culture, we have spaces and social ways to encapsulate the idea of this is creativity, this is problem solving, etc. But those boxes are also in crisis. And what I feel is that if we open and think more from an ecological perspective, not only us humans create things. We can see creativity everywhere in the universe, everywhere in biology, everywhere in physics, and we can stop thinking that creativity is something that you own. And if we relax a little bit that, and we just enjoy not only the possibility of a universe that creates things all the time, everywhere, but that those creations can be combined for new creations themselves. This quantum foam that we see at the most basic level, at the Planck level, but now at all the levels, and we relax a little bit on that, it's an awesome world. It's also very confusing if we deal with the world using boxes. I think it will solve. I think there's going to be a specific crisis, and I think it's kind of similar to what happened with education. If you are an illustrator that operates on the requests, draw this, draw that, even if your art is amazing, maybe this weight is not your creativity that is in crisis. It's how you perform your creativity. The whole process that goes from someone needing something and you responding to that. So those ways to operate with creativity, those ways are in crisis. Produce music for this video, etc. Those ways, but it's not the creativity that is in crisis. It's the economy of the creativity that is in crisis in that case. So we humans, we need to adapt. And if you want to be a creative that lives out of your creativity, etc., you will need new ways to connect with society and also new economical tactics to live out of your creation. And it's a huge crisis. And a lot of you need a lot of meta creativity to solve that creativity problem for sure.
So we are not the only source of creativity now in the world.
We never did.
We are still
Like we are still adding some randomness to the foam, right?
And it's like you can it always change by changing a little bit your definition of creativity. Everything changes, right? My invitation is to open the dial. So it's not trying to convince anyone that creativity is this or that, or intelligence is this or that. Is that inviting ourselves to what if I open the definition of intelligence of creativity, what this implies, and what this implies in terms of tactics for me to live in a creative way, right? It's more about tactics. It's not about fundamentals. Nothing I say today is about fundamentals in the sense I don't want to say this is intelligence, this is not, this is awareness, I'm not interested in that. It's now change your perspective, change the definition, and what opportunities that brings to you. So in the case of my work, I say if intelligence is an ecosystem, let's build very obviously animals interacting as an ecosystem. So it's very direct, the influence of thinking one way or the other. And our culture can kind of do the same. If intelligence is no longer our own human, and actually go to a book about intelligence. I've read several. I am already kind of tired because there are so few books that do not equal the human intelligence with the capability of flying to the moon or this kind of technological achievements. And the message is, in reality, for you, author, intelligence is being able to conquer with technology. So it's something only associated with a particular culture, a particular time, and it happens to be your culture and your time, of course. That's what I will say to the author. And if you look into how the intelligence is being discussed, it always goes to the same stereotype of intelligence. Is what are the examples of intelligence? I choose pollination because I wanted to just show flying to the moon is another example. I'm not saying it's not, but if everyone is pointing to the same things, to our technological achievements, right? Or the scientific perspective, intelligence. Now humans are so intelligent, they can understand themselves because they have science. So they can know, and they can understand the universe because they can now see, for instance, when the universe started. And all those are wonderful achievements, but this is not intelligence. This is just the achievements of your culture. And if we continue associated with one particular culture, not only with humans, but with one particular culture, what intelligence is, we will fall into semantic traps, into philosophical traps, and then later into economical and ecological traps for doing a wrong association, right? So yeah, intelligence is my invitation. Let's relax the definition. Let's assume there could be intelligence in many other ways, creativity in many places and ways. Let's enjoy all of them. Let's protect some of them that we are killing. Be more protective, because if we still think that intelligence plays just in this, and emotions and awareness is just for a few, it's a small club, everything that happens out of the club doesn't matter to us, right? And will be projected into our economy, into our military forces, into our ecological strategies, etc.
I think there's one online.
I also have one more.
But just for the sake of time, maybe we do that, and then we can break into circles and we can continue the discussion and drink. Benji, do you want to do the one online?
Sure, happy to. So Felipe Vega online asked, and I will just read the question. Santiago, maybe you will have to do some interpretation here for me. Given that you mentioned in the math education prompt, parentheses, when you consulted ChatGPT, what kind of foundations will be given to the new generations? Many of the foundations I think we learned are mechanical processes.
So yeah, what if we don't want mechanical process, I'm going to interpret it that way. If that's what we don't want, I don't want it. I don't want it for my kids, for sure. What will be what we want? And it's a horrible question, very difficult. I myself, I tried to answer that particular question by experimenting with my kids since they started interacting with me, let's say linguistically, or even before, just playing with objects. It's I've been experimenting a lot just to try to answer that question. I think it will be an inductive process, not a deductive, meaning that it's more the communities, and it has been through history, that will answer that question. So instead of being like a centralized problem, a centralized discussion that will point to the big answers, and then those answers will spread, I think it's through communities. I believe a lot in schools like the one my kids went. They are no longer there. They grew up. They are in more formalized institutions right now. And this kind of schools is one of the questions. This school works like this. Kids go, if they are interested in something, they write down on a paper, I'm interested in this or that. And the school tries to find contents, teachers, workshops, people that can, sometimes even other kids that share that knowledge. Chess, there are kids that play chess amazingly. So why not do it with our own students, etc. And I taught as mathematics there through that kind of system, but the kids went through all sorts of contents. Of course, they learn languages or they learn a lot of sports. Some kids take just one workshop per week, 1 hour. Some kids spend all the day going through workshops. There are no rules, etc. And I cannot tell that this works for everyone, but when it works, it's fantastic. And my feeling is that we need more experiments like that, right? Also, it was interesting, the interface between these kind of schools and technology. I actually brought technology there, not because again, you have heard me, it's not because I believe technology is on itself like the future of education or something, but because I think these kids could benefit from connecting with technology from a very different perspective, right? From creativity as a tool for playing, for opening opportunities, etc. So the answer again, I think, but it's just one person with ideas. No more than that. I don't pretend to have found any meaningful answer here, but I personally experimented. I think communities should experiment, and new educational ideas will grow out of communities.
Good. Then I think I'm going to wrap it up and we can continue conversation in smaller groups. First of all, another round of applause. I think that was fantastic.